In the Eastern Mediterranean in November 1941, naval warfare is constrained less by boldness than by geometry, timing, and the mechanical limits of submerged propulsion. A German-type VIIC submarine, U-331, operates with a surface speed advantage of barely 4 to 5 knots over capital ships only when undetected, in an underwater endurance defined by approximately 120 to 150 minutes at tactical speed before battery depletion becomes operationally decisive. Doctrine assumes that in confined waters dominated by air patrols, destroyer screens, and predictable fleet movements, such a boat cannot close to effective torpedo range without being detected and destroyed. That assumption rests on probabilities. It does not account for timing errors measured in seconds. On November 25, 1941, HMS Barham sails as part of Force A in the Mediterranean, accompanied by battleships HMS Queen Elizabeth and HMS Valiant, screened by multiple destroyers. Barham displaces over 31,000 tons, carries 15-inch main guns, and maintains a cruising speed in excess of 20 knots. Her underwater protection system is designed to absorb localized damage, not multi-point detonation beneath the keel. The screen is arranged to counter surface and aerial threats, with anti-submarine sweeps optimized for perimeter defense, not for a submerged attacker already inside the formation. U-331 approaches submerged, operating under strict battery economy. At 3 knots, current draw remains below 250 amperes, allowing approximately 3 hours of maneuvering. At 5 knots, draw exceeds 400 amperes, collapsing endurance to under 90 minutes. Speed becomes the primary physical limiter. Every course correction consumes energy that cannot be replenished without surfacing. The commander, Hans Dietrich von Tiesenhausen, commits to a single approach vector, accepting that once detected, escape margins will fall below survivable thresholds. The critical constraint emerges from relative motion. Barham and her consorts alter course periodically, but within a predictable envelope dictated by fleet station keeping. These alterations occur on intervals measured in minutes, not seconds. U-331 exploits the lag between command issuance and helm execution aboard surface ships, a delay of approximately 20 to 30 seconds per maneuver. That delay opens a transient corridor in which relative bearing remains stable long enough for a firing solution to be computed and executed. At approximately 1625 local time, U-331 breaches the inner screen undetected. Hydrophone conditions are degraded by propeller noise from the formation itself. The submarine's depth is held at roughly 12 meters, shallow enough for periscope observation, but deep enough to minimize wake signature. Each periscope exposure lasts under 5 seconds. Longer exposure would produce a visible feather and guarantee detection. Visual data is incomplete but sufficient. Range is estimated at under 400 meters. At this distance, torpedo runtime is measured in seconds, not minutes. U-331 fires a full spread of 4 G7E torpedoes. The decision is dictated by geometry, not aggression. Single-shot probability of kill is insufficient against a battleship with compartmentalized protection. Multiple impacts increase the likelihood of structural failure below the armored belt. Torpedo speed is approximately 30 knots. Time to impact is under 30 seconds. There is no opportunity for evasive maneuver once the wakes are sighted, if they are sighted at all. 3 torpedoes strike HMS Barham on the port side in rapid succession. The spacing between impacts is measured in fractions of a second. The effect is cumulative. Internal bulkheads fail sequentially. Flooding propagates faster than counter-flooding measures can respond. Within minutes, the battleship develops a severe list. As the hull rotates, secondary explosions occur. Magazine detonation follows. The interval between first impact and catastrophic loss is under 4 minutes. The ship capsizes and sinks with massive loss of life. U-331, having expended its torpedoes, is now inside the formation with depleted maneuver options. Battery reserves are insufficient for prolonged evasion. The submarine surfaces unintentionally due to loss of depth control during emergency maneuvers. It is immediately engaged by destroyers. Damage is severe, but not instantly fatal. The boat is eventually abandoned and scuttled. Survival of the commander is incidental. The operational outcome has already been determined. The event contradicts prevailing assumptions not because Doctrine was irrational, but because it underestimated the impact of narrow temporal windows. The British screen functions as designed in aggregate. It fails in a specific interval measured in seconds, when geometry, noise, and human reaction time align unfavorably. No new technology is introduced. No extraordinary heroism is required. The result emerges from the interaction of existing systems operating at the edge of their tolerances. In analytical terms, the sinking of HMS Barham demonstrates that capital ship survivability is not solely a function of armor thickness or compartmentalization, but of exposure time within lethal range. That exposure can be reduced statistically, but not eliminated. A single submarine, constrained by battery capacity, limited speed, and finite torpedo load, can achieve decisive effect if allowed to occupy the correct position for less than 1 minute. The rest of the operational context becomes irrelevant. The loss forces a reassessment of risk models in confined waters. It underscores that screening effectiveness degrades non-linearly once an attacker penetrates the inner perimeter. It also reveals that doctrines built on averages fail against edge cases defined by precise timing. In this instance, success is not a product of persistence, but of convergence. When multiple delays align, helm response, lookout detection, command relay, the system collapses locally, even as it remains robust globally. From that point forward, the Mediterranean War is shaped less by the presence of battleships than by the recognition of their vulnerability under specific constraints. U-331 does not change the balance of forces. It exposes a flaw in the assumptions governing their use. The engagement lasts minutes. Its implications persist far longer. The immediate aftermath does not alter fleet dispositions overnight, but it recalibrates how risk is computed. The sinking of HMS Barham is first treated as an anomaly, a low-probability event produced by an unusually favorable alignment of circumstances. Yet when the engagement is reconstructed frame by frame, the anomaly dissolves. Each component falls within known parameters. The deviation lies not in performance, but in sequencing. British after-action analysis identifies no single failure. Sonar operators report degraded returns caused by cavitation noise from capital ship screws. Lookouts confirm that no periscope feather is observed beyond fleeting disturbances lasting less than 5 seconds. Destroyer commanders note that inner screen spacing, set to maintain maneuver freedom for battleships at 20 knots, creates transient gaps measured in hundreds of meters whenever the formation alters course. None of these elements violates doctrine. Together, they compress reaction time below the threshold required for interception. The critical constraint is reaction latency. From initial periscope exposure to confirmed recognition, the visual chain requires approximately 8 to 12 seconds under ideal conditions. Command relay to helm requires another 10 to 15 seconds. Rudder response at battleship displacement adds a further delay before meaningful course alteration occurs. The total cycle exceeds 30 seconds. At a firing range under 400 meters, that interval is longer than torpedo time to impact. Once the submarine commits to firing inside that envelope, counteraction is no longer a function of intent, but of physics. U-331 success therefore rests on one non-negotiable condition: proximity. Achieving the proximity demands acceptance of terminal risk. Battery capacity at the moment of firing is already below recovery thresholds. At tactical speed, remaining submerged endurance is measured in tens of minutes. There is no viable egress path once the spread is launched. The attack is irreversible not because of bravery, but because the energy budget forbids reversal. The boat trades survivability for effect in a single, constrained transaction. This exchange exposes a broader doctrinal imbalance. Capital ships are protected against sustained threats. They're not optimized for instantaneous, short-range attacks executed within their own defensive envelope. Armor schemes assume damage distribution over time. Anti-submarine screens assume early detection. When both assumptions fail simultaneously, the protective system collapses locally. The collapse is brief. Its consequences are permanent. In operational planning, this forces a reassessment of inter-screen geometry. Reducing spacing increases detection probability, but degrades maneuver freedom and increases collision risk at speed. Increasing spacing preserves maneuverability, but enlarges the penetration window. There is no configuration that eliminates both risks. The constraint is geometric. At fleet speeds above 18 knots, minimum safe separation between destroyers exceeds the minimum separation required to guarantee acoustic coverage. The gap cannot be closed without sacrificing one function to preserve another. Air patrols offer partial mitigation, but not in this context. In November 1941, continuous air cover is not available in the Eastern Mediterranean at the required density. Patrol cycles leave intervals of several hours without overhead surveillance. A submerged submarine operating on batteries is indifferent to air presence until it surfaces. The decisive phase of the attack occurs entirely below the air detection layer. Air power cannot compress the submarine's approach window once it has crossed the inner screen. The Barham sinking thus illustrates a limit case in naval systems design. It shows that layered defenses reduce probability, not possibility. When an attacker accepts total exposure in exchange for a brief firing opportunity, the defender's advantage becomes statistical rather than absolute. The system functions as designed over time. It fails at a point. For U-331, the engagement represents the maximum yield achievable by a single Type VIIC under Mediterranean conditions. For torpedoes expended, one capital ship destroyed, no further offensive capability remains. The submarine's subsequent loss is operationally irrelevant to the outcome already produced. The exchange ratio is determined entirely within a window measured in under 1 minute. Strategically, the implications propagate unevenly. Battleships remain in service. Submarine doctrine remains largely unchanged. What shifts is the internal weighting of assumptions. Fleet commanders begin to treat proximity as the dominant variable. Once a submarine is assessed to be inside a certain radius, the expected loss curve steepens dramatically. Avoidance replaces interception as the preferred response. Distance becomes safety. This adjustment alters deployment patterns over time. Capital ships operate with greater standoff from perceived submarine operating areas. Escort requirements increase. Transit speeds are moderated in constrained waters. These adaptations impose their own costs in fuel, time, and flexibility. None eliminate the underlying vulnerability. They merely redistribute it. In retrospect, the attack on HMS Barham does not demonstrate the strength of U-boat doctrine. It demonstrates the narrow margin within which that doctrine can still produce decisive results. The window is shrinking. The conditions required are increasingly specific. But when they align, even briefly, the effect is disproportionate to the scale of the force involved. The engagement endures in analysis, not because it was repeatable, but because it defined the boundary at which doctrine, geometry, and time intersected and failed. That boundary becomes the real legacy of the Barham sinking. Not a template to be replicated, but a limit to be acknowledged. From late 1941 onward, naval planners increasingly recognized that certain failures cannot be eliminated, only displaced in time and space. The engagement demonstrates that in high-speed fleet operations, the decisive variable is not detection range, but the minimum time required to convert detection into action. Once that time exceeds the attacker's time to effect, the outcome is already fixed. Post-action evaluations quantify this imbalance with uncomfortable clarity. At 20 knots, a battleship covers roughly 10 meters per second. A hard rudder turn produces only marginal lateral displacement within the first 30 seconds due to mass and hydrodynamic inertia. Even an immediate helm order issued at the moment of periscope sighting cannot move the hull far enough to defeat a short-range torpedo solution. Evasion is physically impossible inside a defined radius. That radius, once mapped, becomes a forbidden zone rather than a defended one. This realization alters how capital ships are valued. Their firepower remains unmatched, but their survivability in confined waters is reclassified as conditional. They're no longer treated as platforms that can absorb surprise, but as assets that must prevent surprise altogether. Prevention, however, requires persistent control of time and space, something surface formations alone cannot guarantee against a submerged opponent willing to expend its entire margin in one attempt. For submarine forces, the lesson cuts in the opposite direction. U-331 success is not scalable. It consumes every available resource in a single action. Battery reserves fall below escape thresholds. Torpedo inventory is exhausted. The boat's survival probability drops to near zero the moment the firing sequence begins. The tactic yields maximum effect only once, under conditions that cannot be reproduced without accepting equivalent losses. It is not a doctrine. It is an edge case. As the war progresses, those edge cases become rarer. Escort density increases. Reaction cycles shorten. Air-sea coordination tightens. The time gap exploited by U-331 narrows. By 1943, similar proximity attacks are statistically unlikely outside extreme circumstances. The Barham sinking thus marks not the future of submarine warfare, but the closing of a window that had existed since the introduction of high-speed capital ships without continuous close-in anti-submarine coverage. From a systems perspective, the engagement illustrates how complex military machines fail, not through collapse of a single component, but through synchronization of minor delays. Each delay, visual recognition, command relay, helm response, falls within acceptable limits in isolation. Together, they exceed the tolerance of the system. The failure is emergent, not localized. No individual actor can correct it once the sequence is underway. This insight feeds back into doctrine across navies. It reinforces the shift toward layered, overlapping defenses designed to reduce not just detection gaps, but decision latency. It accelerates investment in sensors that shorten recognition time rather than extend range. It also underscores the value of decentralization, where local commanders are authorized to act without awaiting confirmation. These changes aim to compress the response cycle below the attacker's execution window. Yet, even with these adaptations, the fundamental constraint remains. Physics imposes minimum times for perception, decision, and motion. Those times cannot be reduced to zero. The Barham engagement proves that any system operating near its limits will eventually encounter a sequence that defeats it. The role of doctrine is not to deny that possibility, but to make it rare enough that its strategic impact remains acceptable. In that sense, U-331's attack achieves lasting significance not by altering the course of the Mediterranean campaign, but by clarifying the cost of error in high-density naval environments. A single lapse measured in seconds can negate years of design, thousands of tons of steel, and the labor of entire crews. The loss is sudden. The cause is incremental. When viewed against the broader arc of the war, the sinking of HMS Barham sits at an inflection between eras. It belongs to a moment when submarines could still exploit proximity against surface fleets, and when those fleets had not yet fully adapted to the temporal demands of underwater threats. That moment passes. The margins close, but the lesson remains embedded in naval thought long after the specific conditions disappear. The engagement endures in analysis because it defines a boundary condition. It shows where doctrine holds and where it breaks. It demonstrates that success and failure can hinge on intervals shorter than a minute, shaped by machinery, training, and the immutable inertia of mass moving through water. In the end, Barham is not sunk by a bold idea, but by a system operating precisely as designed, until for a few seconds it is not. From this boundary condition, naval operations evolve toward managing proximity as a measurable risk rather than an abstract threat. Fleet movement tables begin to incorporate exclusion radii derived from worst-case submarine approach speeds and minimum reaction cycles. If a submerged attacker can traverse 300 to 400 meters in under 60 seconds, and if the defender's combined perception, decision, actuation loop cannot compress below 35 to 40 seconds, then any contact inside that radius is treated as functionally lethal. The calculation is simple. its consequences are restrictive. In practical terms, this drives changes in formation behavior. Capital ships reduce speed in confined waters not to improve maneuverability, but to reduce the kinetic penalty of delayed helm response. At 15 knots instead of 20, lateral displacement during a hard turn increases by several meters within the same 30-second window. The gain is marginal, but margins are now counted in meters and seconds, not in tactical intent. Slower speed also reduces propeller cavitation, improving sonar conditions for escorts. Speed, once a defensive asset, becomes a liability when it shortens reaction margins. Escort commanders adjust patrol geometry accordingly. Inner screens tighten, but only to the point where collision risk at reduced speed remains acceptable. This produces formations that are denser but slower, trading area coverage for temporal control. The number of destroyers required to maintain continuous acoustic overlap increases. The limiting factor becomes availability, not doctrine. Every additional escort assigned to a capital ship is one less available for convoy duty. Protection is finite and must be allocated where the risk curve steepens fastest. For submarine commanders, the Barham engagement clarifies the cost structure of close-range attacks. Achieving decisive effect requires penetration to within a zone where escape probability collapses to near zero. The transaction is asymmetric but terminal. One boat for one ship. As escort density and reaction speed improve, the probability of reaching that zone without prior detection falls sharply. By 1942, the expected value of such attacks declines below acceptable thresholds except under exceptional circumstances. The tactic persists only at the margins, where geography compresses space and time beyond the ability of escorts to adapt. This interaction feeds back into design priorities. Surface navies invest less in incremental armor improvements and more in reducing latency. Fire control, damage control, and propulsion upgrades are evaluated not only for performance, but for response time. Submarine forces focus on endurance extensions that delay the point at which a single approach must be made. Batteries with higher capacity, snorkel systems to permit submerged charging, and tactics emphasizing standoff engagement all aim to avoid the terminal geometry demonstrated by U-331. Yet these adaptations do not erase the underlying constraint. They merely shift it. The minimum reaction time imposed by human cognition and mechanical inertia remains. The minimum execution time imposed by torpedo run physics remains. Where these intervals overlap unfavorably, vulnerability persists. The Barham sinking, thus, serves as a reference case against which later systems are measured. Each improvement is assessed by how much it widens the temporal gap between detection and effect. As the war progresses, that gap generally widens in favor of the defender. Reaction cycles shorten through better training and delegation. Detection improves through refined sonar and radar integration. The lethal radius shrinks. Submarines are forced to fire from longer ranges, increasing torpedo runtime and restoring the defender's ability to maneuver. The edge case recedes. It does not disappear, but becomes increasingly difficult to reach. In this way, the Barham engagement marks a point of maximum tension between opposing constraints. It occurs at a moment when submarine approach speed, torpedo performance, and surface fleet reaction latency intersect at a narrow overlap. Before this moment, defenses are insufficiently dense. After it, they are sufficiently responsive. The event occupies a transient window in the evolution of naval systems. Understanding it requires abandoning narratives of surprise or audacity. The decisive factor is alignment. Systems built to operate safely within certain envelopes fail when those envelopes intersect. U-331 succeeds not by breaking the rules of naval warfare, but by operating precisely within the small region where those rules contradict one another. The result is catastrophic, brief, and unrecoverable. That is why the sinking of HMS Barham continues to appear in technical and doctrinal studies long after the specific conditions of 1941 vanish. It is not a lesson about submarines or battleships alone. It is a lesson about how complex military systems fail when time, geometry, and energy converge faster than command can respond. As these lessons propagate, naval warfare increasingly internalizes the idea that control of time is as decisive as control of space. Engagement planning begins to assume that any contact resolved inside a compressed temporal envelope cannot be reversed by superior firepower alone. The emphasis shifts to preventing convergence in the first place. Routes are selected to maximize detection lead time. Maneuvers are simplified to reduce command latency. Authority is delegated downward so that responses occur without confirmation loops that add seconds. Each measure trims small increments. Together, they widen the gap between perception and effect. The Barham case provides a quantitative baseline for this transformation. Analysts model the engagement by decomposing it into discrete intervals: seconds for visual recognition, seconds for command relay, seconds for helm response, seconds for torpedo transit. When summed, these intervals exceed the margin available at short range. Reducing any single interval yields marginal benefit. Reducing several in parallel yields a step change. This realization drives integrated solutions rather than isolated improvements. Sensors are paired with automated alerts. Helm procedures are standardized to remove verbal ambiguity. Drills emphasize immediate action over verification. The system is tuned to shave seconds. Submarine doctrine reacts in parallel by prioritizing approaches that preserve optionality. The goal becomes to avoid the point of no return demonstrated by U-331. Commanders favor firing solutions that allow a post-launch dive and withdrawal within remaining battery margins. This requires longer ranges and higher torpedo reliability. It also demands precise targeting to offset the increased evasion window afforded to the defender. Where these conditions cannot be met, attacks are deferred. Opportunity is weighed against survivability with increasing conservatism. The interplay produces a narrowing band of feasible engagements. Close-range attacks remain possible, but only where geography compresses formations or where environmental noise degrades detection sufficiently to delay reaction. Straits, coastal waters, and high-traffic areas retain elevated risk. Open seas do not. The Mediterranean in late 1941 offers a unique confluence of constrained maneuver space, limited air coverage, and evolving doctrine. By mid-1942, that confluence is rare. From a system standpoint, the Barham sinking illustrates the cost of operating near performance ceilings. Capital ships push speed to maximize strategic mobility. Submarines push proximity to maximize lethality. Both operate near limits where small delays produce outsized consequences. When two systems at their limits intersect, stability depends on which can compress time more effectively. On November 25, 1941, the attacker compresses time faster than the defender can respond. The durability of this lesson lies in its generality. It applies beyond naval warfare. Any domain where detection, decision, and action occur in sequence is vulnerable when execution time undercuts response time. Armor, redundancy, and mass mitigate damage over time. They do not negate instantaneous effects delivered within an uninterruptible window. The Barham engagement makes this explicit in steel and water. As subsequent operations confirm, preventing recurrence does not require eliminating submarines or battleships. It requires ensuring that the window exploited by U-331 does not reopen. That objective is achieved not by a single innovation, but by cumulative reductions in latency across the system. When the sum of those reductions drops below the attacker's minimum execution time, the balance shifts. The edge case closes. In that sense, the engagement stands as a calibration point. Before it, assumptions about survivability tolerate certain delays. After it, those delays are reclassified as unacceptable. Training, equipment, and doctrine align accordingly. The war moves on, but the boundary remains marked. Thus, the sinking of HMS Barham persists in analysis not as a dramatic anomaly, but as a precise demonstration of where and how a complex defensive system can fail. It shows that decisive outcomes can hinge on intervals measured in seconds, constrained by geometry and energy, and that once those intervals align unfavorably, no amount of intent or capability can restore control. Once that boundary is recognized, Operational behavior shifts from reactive correction to preemptive denial. Fleet commanders begin to treat proximity not as a tactical circumstance, but as a failure state. Any indication that a submerged contact may exist within a defined inner radius triggers immediate dispersal or withdrawal rather than pursuit. The decision is not driven by fear of loss, but by arithmetic. Inside that radius, the defender's options collapse faster than any corrective measure can be executed. This logic reshapes how time is allocated during operations. Maneuver plans are simplified to reduce the number of decision points. Fewer maneuvers mean fewer command transmissions, fewer confirmation loops, and fewer seconds lost to coordination. The goal is not elegance, but compression. Every avoided order preserves reaction margin. Every preserved second expands survivability. Complexity becomes a liability when the decisive interval is measured in half minutes. The Barham engagement also clarifies the role of noise as a systemic constraint. In a high-speed formation, self-generated acoustic interference masks the very sensors intended to provide warning. Propeller cavitation at 20 knots degrades sonar performance across the inner screen. Reducing speed by even 3 to 5 knots lowers cavitation intensity enough to restore partial detection capability. The trade-off is immediate. Reduced speed extends transit time and increases exposure elsewhere. Again, the decision is numerical, not conceptual. Time gained in detection offsets time lost in movement only if the engagement window is sufficiently compressed. For submarines, the same arithmetic applies in reverse. Approaching a formation at low speed preserves battery life but increases exposure duration. Increasing speed shortens exposure but accelerates energy depletion. The optimal point exists only briefly, where remaining battery capacity exceeds the energy cost of approach and firing, but not of escape. U-331 operates precisely at that point. Any deviation in timing, any earlier detection, any later firing, would shift the balance below viability. The success is therefore brittle. It tolerates no error. This brittleness is what ultimately limits replication. As defensive systems improve, the viable window narrows further. Reaction times fall. Detection reliability rises. The minimum distance at which a submarine can fire and still expect effect expands beyond what battery and torpedo performance can support. The attack geometry demonstrated in 1941 becomes increasingly unattainable, not because it is forbidden, but because it is unsustainable. In doctrinal terms, the engagement reinforces the distinction between possibility and practicality. That something can occur does not mean it can be planned for repeatedly. U-331 proves that a Type VIIC can sink a battleship under specific constraints. It does not prove that such outcomes can be generated on demand. Doctrine evolves to reflect the latter, not the former. Systems are designed to perform reliably, not heroically. As the war advances, this distinction hardens. Capital ships operate with layered defenses optimized to prevent inter-zone penetration. Submarines shift toward convoy interdiction, where targets move more slowly and reaction cycles are longer. The environment that allowed the Barham attack fades. The logic it exposed, however, remains embedded. From a broader analytical perspective, the engagement demonstrates how military systems fail at the edges of their design envelopes. Each component performs within specification. Sensors detect as expected. Commands are issued promptly. Machinery responds correctly. Yet the aggregate response arrives too late because the sum of acceptable delays exceeds the margin available. Failure emerges not from breakdown, but from alignment. That alignment is rare, but not random. It arises where multiple systems operate near maximum performance simultaneously. High speed, dense formations, limited air cover, and constrained maneuver space combine to compress time. Remove any one element and the outcome changes. This sensitivity explains both the dramatic nature of the Barham loss and its isolation. In the end, the significance of U-331's attack lies not in its tactical novelty, but in its analytical clarity. It strips the engagement down to fundamentals: distance, speed, reaction time, and energy. It shows that when these variables intersect unfavorably, Outcome precedes intention. Control is lost not because decisions are wrong, but because they are late. That realization persists beyond the Mediterranean, beyond battleships, and beyond submarines. It informs how modern forces think about saturation, surprise, and system resilience. The sinking of HMS Barham endures not as a story of audacity, but as a case study in how seconds, once lost, cannot be recovered, and how, in war, those seconds can outweigh thousands of tons of steel. From this point, the analytical value of the Barham engagement shifts from explanation to calibration. Subsequent exercises and war games begin to encode the event not as a narrative, but as a boundary condition. Planners treat it as a reference scenario where the defender's response curve intersects the attacker's execution curve at a point too late to matter. Any future configuration that reproduces similar timing relationships is flagged as unacceptable, regardless of theoretical firepower or armor resilience. This calibration influences how losses are interpreted. A capital ship destroyed by air attack or surface gunfire is understood as the result of contested superiority. A capital ship destroyed by a single submarine inside its own screen is classified differently. It indicates a lapse in temporal control. The remedy is therefore sought not in heavier weapons, but in shortening loops. Training emphasizes immediate helm action on ambiguous cues. Ambiguity itself becomes actionable. The threshold for response is lowered because the cost of false positives is judged smaller than the cost of delayed certainty. The same logic drives changes in command architecture. Authority is decentralized so that destroyer captains can act on partial information without awaiting confirmation from the flagship. This removes an entire relay step, saving 10 to 15 seconds. In isolation, the saving appears trivial. In aggregate, it shifts the response cycle below the attacker's minimum execution time. The Barham case demonstrates that such marginal gains can be decisive. Technically, the engagement also reframes the role of mass. Battleships rely on mass to absorb damage and to stabilize motion. That same mass, however, imposes inertia. At 31,000 tons displacement, Barham's angular acceleration under hard rudder is limited by hydrodynamic resistance. The ship cannot pivot fast enough to evade a threat detected inside a few hundred meters. Mass that confers survivability against long-range fire becomes a liability against close-range underwater attack. This trade-off is structural. It cannot be resolved by training or courage. For submarines, mass operates inversely. The Type Vike's small size allows rapid changes in depth and heading, but only within the limits imposed by battery capacity and trim control. Once those limits are exceeded, the boat becomes unstable. U-331 accepts this instability knowingly. The attack consumes not just torpedoes, but the remaining margin of control. After firing, the submarine exists in a degraded state where survival depends on factors largely outside its control. The system has crossed its own point of no return. This mutual crossing of thresholds, defender too slow to react, attacker too depleted to escape, defines the engagement symmetry. Both sides operate beyond recovery limits. The difference lies in timing. The submarine reaches its limit after delivering effect. The battleship reaches its limit before it can respond. The sequence is asymmetric in outcome, but symmetric in constraint. As anti-submarine warfare matures, the goal becomes to invert this sequence. Defenders seek to force submarines to reach depletion before they can deliver effect. This is achieved by extending detection ranges, shortening reaction times, and imposing repeated interruptions that drain energy reserves. The Atlanta campaign later demonstrates this inversion at scale. Barham represents the earlier configuration, where the inversion has not yet occurred. In doctrinal literature, the engagement is increasingly cited as an example of terminal geometry. Once an attacker occupies a position from which time to effect is shorter than time to response, the engagement is already decided. All prior measures have failed. The only defense is to prevent that geometry from forming. This insight shifts emphasis from fighting inside the envelope to managing the envelope itself. Viewed through this lens, The sinking of HMS Barham is not a failure of vigilance or a triumph of daring. It is the outcome of two systems optimized for different threat models intersecting at an unanticipated point. The British fleet is optimized for air and surface threats at distance. The German submarine is optimized for covert approach and sudden release of stored energy. Where these optimizations overlap temporally, the release overwhelms the response. The endurance of the case in professional study lies in its precision. The margins are narrow and measurable. Reaction delays of seconds, distances of hundreds of meters, energy budgets of minutes. There is no ambiguity about why the outcome occurs once those values are set. The engagement can be replayed analytically with the same result every time, provided the initial conditions are unchanged. As the war continues, those initial conditions are deliberately altered. The margins widen, the window closes, but the analytical clarity remains. Barham is remembered not because it was typical, but because it was exact. It shows with uncommon clarity how, in modern war, control could be lost not through misjudgment, but through timing, and how, once lost, it cannot be regained by force alone. Beyond its immediate naval context, the Barham engagement begins to function as a generalized warning about systems operating at saturation. Once performance margins shrink to the point where acceptable delays overlap with lethal execution times, resilience becomes illusory. The system appears robust in aggregate, yet remains fragile at specific nodes. These nodes are not geographic. They are temporal. They exist only for seconds, but when occupied, they invalidate the entire defensive architecture. Naval planners internalize this by shifting emphasis from absolute capability to margin management. The question ceases to be whether a formation can repel an attack and becomes whether it can guarantee sufficient temporal separation between detection and effect under worst-case conditions. Worst case is no longer theoretical. U-331 demonstrates that a determined attacker can force the worst case by accepting self-exhaustion. That realization changes the definition of acceptable risk. In practical fleet operations, this leads to the concept of enforced distance. Not standoff for firepower, but standoff for time. Formations are arranged so that any submerged contact detected inside a given radius triggers immediate withdrawal rather than engagement. The withdrawal itself is calculated. At 15 knots, a battleship increases separation by approximately 7.5 meters per second relative to a submerged submarine limited to 3 knots. Over 120 seconds, this yields nearly 900 meters of additional distance, enough to move outside the zone where torpedo runtime undercuts reaction time. The maneuver is not elegant, but it is mathematically sufficient. This doctrine accepts that not all contacts can be neutralized. Some must be escaped. That acceptance marks a departure from earlier assumptions of dominance. Control is redefined as the ability to deny convergence, not to defeat the converging unit. The Barham sinking accelerates this shift by demonstrating the cost of insisting on engagement inside compressed envelopes. For submarine forces, the same logic reinforces the limits of opportunistic success. U-331 achieves a decisive result by converting stored energy into immediate effect. That conversion leaves no residual capability. The submarine becomes inert once the transaction is complete. In energy terms, the attack consumes nearly 100% of the boat's remaining offensive and evasive margin. There is no reserve. Any system that relies on total expenditure for success cannot sustain repeated operations. Its value lies in isolated shocks, not in prolonged pressure. As escort density increases and coordination improves, the feasibility of such total expenditure attacks declines. Submarines are increasingly forced to choose between conserving energy and accepting detection. The middle ground narrows. By late 1942, most successful submarine actions occur against targets whose speed and escort geometry allow longer engagement windows. Battleships in formation no longer present such windows except under rare conditions. The analytical afterlife of the Barham case extends into training curricula. Naval officers study it not for its narrative, but for its timing diagrams. Exercises replicate the sequence with altered parameters, reduced speed, tighter screens, faster command loops. Each variation tests whether the lethal window persists. In most cases, it does not. The outcome shifts from catastrophic to recoverable. This reinforces the central conclusion. The original event occupies a narrow slice of parameter space. That slice exists because multiple systems reach local maxima simultaneously. The battleship formation operates at high speed to maintain operational tempo. Escorts are spaced to balance coverage and maneuver. Air support is intermittent due to range limitations. The submarine approaches with sufficient battery reserved to maneuver aggressively, but insufficient to escape afterward. All variables align. Remove anyone, and the sequence fails. From a broader strategic perspective, this alignment underscores why such events resist repetition. War evolves by pushing systems away from demonstrated failure modes. Once exposed, those modes are either mitigated or avoided. The Barham's sinking thus contributes to its own isolation. Its lessons are absorbed precisely because its consequences are so clear. In retrospect, the engagement defines the end of an era in which capital ships could assume that layered defenses alone guaranteed safety in all contexts. It also defines the limit of what a single conventional submarine can achieve against a fully alert fleet. The encounter sits at the intersection of these two limits, marking the point where both doctrines briefly overlap and then diverge. As naval warfare continues to industrialize, the importance of such boundary cases grows rather than diminishes. They reveal where theoretical safety margins collapse under real conditions. They show how quickly advantage can evaporate when time, rather than firepower, becomes the dominant currency. And they remind planners that in complex systems, the most dangerous threats are not those that persist, but those that compress themselves into intervals too short to counter. The sinking of HMS Barham endures, therefore, not as a singular triumph or a singular failure, but as a precise demonstration of how modern war punishes delay. It shows that once action falls behind effect by even a few seconds, the outcome is no longer contestable. Control is lost not gradually, but instantaneously. And when it is lost, no reserve of strength can buy it back. From this stabilized understanding, Naval Command increasingly treats time compression as the primary enemy. The objective is no longer to destroy every potential attacker, but to ensure that no attacker can ever force the system into a terminal timing mismatch. This requires discipline more than aggression. Formations avoid unnecessary speed changes that introduce command latency. Course alterations are minimized to reduce helm cycles. Each maneuver is evaluated not for tactical elegance, but for its impact on reaction bandwidth measured in seconds. The Barham case also reframes the role of information quality. Perfect information arriving late is operationally useless. Imperfect information arriving early can be decisive. Lookout reports that would previously have been dismissed as uncertain are now treated as triggers. The decision threshold shifts downward because the cost of false maneuver is lower than the cost of delayed certainty. This trade is quantifiable. A false turn costs fuel and position. A late turn costs the ship. When the engagement window is under 40 seconds, the balance is unambiguous. Technically, this shift accelerates the integration of sensor outputs. Sonar, optics, and later radar are fused not to improve resolution, but to reduce confirmation time. Correlation replaces certainty. Two weak indicators aligned within a 10-second window are acted upon as if they were one strong contact. This fusion shortens the detect, decide, act loop by eliminating serial validation. The Barham engagement demonstrates that serial processes are incompatible with compressed threat envelopes. Submarine commanders observe the same compression from the opposite side. Opportunities that once allowed for incremental adjustment now demand immediate commitment. The firing solution must be computed and executed without refinement. There is no time to optimize gyro angles beyond a narrow tolerance. Range estimation errors of even 50 meters materially affect outcome when torpedo runtime is under 30 seconds. The requirement shifts from precision through iteration to precision through preparation. This places a premium on prior calibration. Crews drill firing sequences until execution becomes reflexive. The objective is to reduce internal decision time to near zero. Human latency is treated as a variable to be minimized, not an immutable constant. Yet, even with perfect drill, the physical limits remain. Torpedoes still require time to arm. Gyros still require stabilization. These processes impose irreducible delays measured in seconds. The margin is narrow. As anti-submarine warfare matures, defenders seek to force submarines to expend these irreducible delays earlier at greater range. Long-range detection does not guarantee kill, but it restores temporal depth. Each additional minute of warning expands the defender's option set exponentially. Maneuver becomes viable again. Evasion replaces inevitability. The lethal radius contracts. The Mediterranean experience feeds directly into later Atlantic practices. Escort commanders learn to value early contact over continuous contact. Breaking a submarine's approach at 2,000 meters is more valuable than tracking it at 400. The former preserves time. The latter consumes it. This insight alters pursuit behavior. Escorts prioritize barrier placement and predictive interception rather than close-in harassment when capital ships are present. In this evolving environment, the conditions that allowed U-331 to succeed become increasingly rare. The intersection of high fleet speed, incomplete air cover, and permissive interscreen geometry narrows. Each adjustment removes 1 degree of freedom. The attack remains possible in theory. In practice, it requires a convergence that operational planning actively prevents. What persists is the analytical lesson. Systems fail not at their weakest points, but at their fastest. Where action outpaces response, strength is irrelevant. The Barham sinking remains instructive because it exposes this principle without ambiguity. The sequence can be timed, measured, and replayed. There is no hidden variable. The outcome follows directly from the parameters. As a result, modern naval doctrine increasingly treats time as a resource to be conserved and protected. Distance, speed, and formation are all subordinate to maintaining reaction margin. Once that margin collapses, control collapses with it. The Barham engagement stands as a precise demonstration of this collapse, occurring not through surprise alone, but through the deterministic alignment of seconds, meters, and mechanical inertia. In the broader trajectory of the war, this understanding contributes to a gradual but irreversible shift. Capital ships remain potent, but they operate within stricter envelopes. Submarines remain dangerous, but only when they can compress time beyond the defender's ability to respond. Between these envelopes lies the operational space where most of the war is now decided, not by singular dramatic encounters, but by the continuous management of margins that prevent such encounters from ever forming again. As these margins are codified, operational planning increasingly resembles constraint management rather than maneuver warfare. Timetables replace intentions. Routes are selected not for shortest distance, but for maximum warning depth. Fleet movements are synchronized with patrol cycles so that no segment of a transit coincides with known submarine operating patterns without sufficient temporal buffer. The buffer is defined numerically. If expected warning time falls below 60 seconds, the route is rejected regardless of strategic convenience. This discipline alters the rhythm of naval operations. Speed becomes variable rather than constant. High speed is used only where early detection is assured. In contested zones, speed is deliberately reduced to restore acoustic clarity and extend reaction windows. The trade is explicit. A reduction from 20 to 16 knots increases transit time, but it also increases sonar effectiveness and reduces cavitation noise enough to recover tens of seconds in detection lead. Those seconds are worth hours of schedule disruption. The same arithmetic governs night operations. Darkness degrades visual detection, but does not eliminate it. Periscope wakes remain visible against moonlit water for fractions of a second. Those fractions are now sufficient. Lookouts are trained to act on disturbances lasting less than 2 seconds. The threshold for reporting is lowered. Reporting latency is minimized by prearranged signals. Each procedural change removes another small delay from the chain. The cumulative effect is decisive. For submarines, the compression of margins forces a shift in target selection. Capital ships in formation become opportunistic targets rather than objectives. The expected value of an attack is recalculated to include near certain loss of the boat if proximity thresholds are crossed. As escort density and reaction speed improve, that expected value turns negative. Submarines redirect effort towards slower targets with longer decision cycles. The environment that produced Barham is no longer dominant. This redirection does not negate the relevance of the case. It confirms it. The attack defines the limit at which a submarine can still impose catastrophic effect on a heavily defended target. Once defenses evolve to push engagements outside that limit, the tactic ceases to be viable. The boundary holds. The system adapts around it. In training and analysis, the Barham engagement is repeatedly decomposed into time slices. Analysts vary one parameter at a time. Increase reaction speed by 5 seconds. Increase detection range by 200 meters. Reduce fleet speed by 3 knots. In each variation, the outcome shifts abruptly once the cumulative response time drops below torpedo runtime. The transition is not gradual. It is binary. Either the system recovers control or it does not. This reinforces the understanding that margins are not continuous buffers, but thresholds. The implication extends to command culture. Leaders are conditioned to respect thresholds even when pressure favors risk. The temptation to maintain speed, to press forward, to rely on robustness is countered by quantitative reminders of how little delay is required to negate those advantages. The Barham case becomes a caution against overconfidence in mass and firepower when time is scarce. As the war progresses, the number of such boundary cases diminishes. Systems are redesigned to avoid them. Yet the underlying principle persists. Wherever technology compresses execution time faster than response time can be reduced, vulnerability emerges. The specific platforms change. The geometry remains. In this sense, the sinking of HMS Barham transcends its immediate context. It becomes an early illustration of a pattern that recurs whenever offense can concentrate effect into intervals shorter than defensive decision cycles. The lesson is not that defenses are futile, but that they must be evaluated against worst-case timing, not average performance. The Mediterranean in late 1941 provides a snapshot of this imbalance. Submarine approach speed, torpedo performance, and fleet reaction latency intersect at a narrow overlap. That overlap produces a decisive outcome. As conditions change, the overlap disappears. The system stabilizes, but the memory of its existence shapes future behavior. What endures is the recognition that control in modern warfare is conditional and temporal. It exists only as long as response can keep pace with execution. Once execution outruns response, control evaporates instantly. No reserve of strength can compensate. The Barham engagement captures this moment with uncommon clarity. From that point forward, naval doctrine increasingly treats time not as an abstract dimension, but as a consumable resource. It must be protected, replenished, and denied to the adversary. Distance, formation, and speed are merely tools to manage it. When time is preserved, systems function. When it is lost, systems fail. The story of U-331 and HMS Barham thus concludes not with the sinking itself, but with the enduring recalibration of forces. It marks the point at which seconds become decisive currency, and where the management of those seconds determines whether power can be exercised or whether it collapses under its own inertia. With this recalibration internalized, the operational vocabulary itself shifts. Terms like screen integrity and coverage give way to phrases that implicitly encode time. Warning depth, response bandwidth, execution margin. These are not rhetorical changes. They reflect a quantitative reorientation. A screen is no longer judged by how much space it covers, but by how many seconds it can reliably generate between first indication and irreversible effect. This reorientation alters how failures are investigated. When later incidents occur, inquiries focus less on whether a contact was missed and more on how much time was lost at each stage. A delayed report of 6 seconds. A hesitated helm order of 8 seconds. A rudder response lag of 12 seconds. Each delay is cataloged not as error, but as cost. When summed, these costs determine outcome. Responsibility becomes systemic rather than individual. The Barham engagement thus becomes an early example of what later doctrine will describe as time domain vulnerability. In such vulnerabilities, defensive strength is irrelevant once the attacker enters a zone where the defender's time budget is already overspent. Inside that zone, additional sensors, thicker armor, and heavier escorts contribute nothing. The only effective defense is to prevent entry. The system's success is measured by how rarely it allows that condition to occur. This perspective also reframes the role of luck. The attack on Barham is not treated as fortunate coincidence, but as deterministic alignment. The parameters are known. The overlap is narrow, but real. Given enough trials, it will be occupied. The task of defense is therefore not to hope it will not be occupied, but to reduce the number of trials and the width of the overlap. Probability is managed through structure, not optimism. For submarines, the same analysis clarifies the diminishing returns of audacious tactics. Approaches that rely on extreme proximity consume all remaining margin in a single act. They succeed only if nothing disrupts the sequence. As defensive systems mature, the likelihood of disruption increases. The expected value of such tactics declines sharply. Submarine doctrine evolves toward engagements that preserve temporal flexibility rather than exhaust it. Survival becomes a prerequisite for effectiveness, not an afterthought. The Mediterranean theater illustrates this transition earlier than the Atlantic because its geography compresses space and amplifies time effects. Narrow seas, predictable routes, and limited air coverage produce sharper thresholds. When those thresholds are crossed, outcomes are immediate. The Barham sinking occurs at the point where old assumptions meet new constraints. It is not an aberration, but a symptom of transition. As naval systems continue to evolve, the specific technologies change, but the underlying logic persists. Faster weapons shorten execution time. Automation shortens response time. The contest becomes one of relative compression. Whoever can compress execution faster than the other can compress response gains decisive advantage, until the cycle reverses. In 1941, the submarine briefly holds that advantage in a narrow band. By 1943, escorts and air patrols reclaim it across most theaters. The shift is not absolute, but it is sufficient to change behavior. Capital ships become more cautious. Submarines become more selective. The catastrophic intersection demonstrated by U-331 and Barham becomes increasingly difficult to reproduce. Yet its analytical value does not diminish. It remains a reference because it isolates the mechanics of failure with unusual clarity. No extraordinary technology is involved. No radical doctrinal innovation is required. The engagement can be understood entirely in terms of distance, speed, reaction time, and energy expenditure. These variables are universal. They apply wherever systems interact under pressure. The enduring lesson is therefore not about submarines or battleships, but about the structure of modern conflict. When systems operate near their performance limits, outcomes hinge on margins measured in seconds. Control is conditional. It exists only while response can outrun effect. Once that condition is violated, collapse is immediate and total. In that sense, the sinking of HMS Barham marks a moment when naval warfare becomes fully temporalized. Space and firepower remain important, but they're subordinated to timing. The side that manages time more effectively dictates not just engagements, but the conditions under which engagements can occur. U-331 briefly seizes that advantage. The system adapts. The advantage shifts. The principle remains. Once naval warfare is framed in this temporalized way, planning acquires a different rigidity. Flexibility is no longer a virtue if it expands the decision cycle. Pre-authorization replaces deliberation. Maneuver sets are reduced to a limited menu whose execution times are known in advance. If a response cannot be executed inside a defined window, often set at 30 to 45 seconds, it is removed from the repertoire entirely. The aim is not to maximize choice, but to guarantee speed. The Barham case informs these thresholds directly. Analysis shows that from the first moment at which a submarine inside 400 meters becomes aware of its target, the remaining time to irreversible effect is bounded by torpedo arming delay, gyro stabilization, and runtime. Even at minimum settings, this chain completes in under 30 seconds. Any defensive action whose execution exceeds that interval is irrelevant. That fact becomes embedded in planning assumptions. Defensive systems are evaluated against the attacker's fastest possible sequence, not against average behavior. This perspective alters the perceived value of early warning. Detection at 2,000 meters does not simply provide more time. It changes the quality of time available. At that range, decisions can be sequential. Verification is possible. Commands can propagate through formal channels. At 400 meters, none of this applies. Time exists only as a continuous block that must be consumed instantly or not at all. The difference is qualitative, not quantitative. As a result, escort tactics increasingly emphasize barrier effects over pursuit. The goal is not to chase a submarine once detected, but to deny it the approach geometry required to enter the terminal zone. This is achieved through predictive placement rather than reactive maneuver. Destroyers are positioned where a submarine would need to pass, not where it is last heard. Prediction trades uncertainty for time. Even an imperfect prediction can restore tens of seconds of margin, which is enough to re-establish control. For submarines, this shift further constrains offensive options. Approaches that depend on stealth alone become insufficient. Stealth must be paired with timing favorable enough to offset improved prediction. This requires either environmental masking, such as heavy sea states or high ambient noise, or operational distraction that saturates defensive attention. Both conditions are transient and difficult to manufacture deliberately. The opportunity space contracts. The sinking of HMS Barham thus becomes a reference for the last moment at which a single submarine could, under normal fleet conditions, impose catastrophic loss on a capital ship without prior engagement. Later cases approach this threshold but rarely cross it. The conditions tighten. Reaction cycles shrink. Detection reliability improves. The lethal overlap recedes. Yet the fundamental insight persists. Systems fail not because they are weak, but because they are optimized for the wrong envelope. Barham is protected against sustained attack, not instantaneous convergence. U-331 is optimized for brief release of stored energy, not for survival afterward. Where those envelopes intersect, outcome is fixed before either side can adapt. This realization influences post-war naval architecture and doctrine. Designers place increasing emphasis on automated responses that bypass human latency. Alarm systems are built to trigger maneuvers directly. Weapon systems are slave to sensors to reduce delay. The objective is not to outthink the attacker, but to outpace it. Human judgment remains essential, but it is repositioned upstream, where time is abundant. In historical hindsight, the Barham engagement marks a point at which naval warfare exposes its dependence on time compression more clearly than ever before. The event is not dramatic because of what happens, but because of how little time there is for anything else to happen. Seconds dominate outcomes. Once those seconds are lost, recovery is impossible. That is why the engagement retains analytical relevance beyond its immediate tactical context. It defines a boundary condition that recurs whenever weapon execution time approaches or undercuts defensive response time. The platforms change. The sensors improve. The weapons accelerate. The logic remains. U-331 does not succeed because doctrine is wrong. It succeeds because doctrine, machinery, and human reaction are aligned just slowly enough to be overtaken by effect. When that alignment shifts, even slightly, the outcome changes completely. The Barham sinking, therefore, stands not as an argument for audacity, but as a precise demonstration of how modern military systems fail when time, geometry, and energy converge faster than command can respond. As this understanding diffuses, the strategic meaning of individual ships diminishes relative to the systems that sustain or constrain them. A battleship is no longer evaluated primarily by its armament or armor scheme, but by how its presence affects the temporal geometry of an entire formation. if its speed, displacement, and maneuver characteristics compress reaction margins for escorts. It becomes a liability in certain environments regardless of its firepower. The Barham loss accelerates this reclassification. Capital ships remain symbols of power, but they are increasingly treated as time-sensitive assets whose employment must be justified by sufficient warning depth. Operational planning reflects this shift through the concept of temporal layering. Outer layers exist to provide hours of warning. Middle layers exist to provide minutes. Inner layers exist only to prevent catastrophic compression into seconds. Each layer has a defined function and a defined failure mode. The Barham engagement demonstrates what happens when the outer and middle layers fail silently, and the inner layer is asked to compensate. It cannot. Inner defenses are not designed to create time. They only consume it. This leads to a more conservative use of force in constrained theaters. Fleets accept reduced tempo to preserve margin. Movements are scheduled to avoid periods when air cover cannot be guaranteed. Transits are delayed rather than rushed. These decisions appear cautious on the surface, but they are grounded in arithmetic. A delay of several hours to ensure continuous patrol coverage is preferable to a transit conducted with a warning depth measured in seconds. Time spent waiting is recoverable. Time lost at the moment of engagement is not. For submarine operations, the same arithmetic imposes a ceiling on ambition. U-331 demonstrates that maximum effect is achievable only by expending all remaining margin in a single act. As defensive systems improve, the conditions required for such expenditure become rarer. Submarines that survive longer do so by avoiding terminal geometries altogether. They trade potential decisive effect for sustained presence. The role of the submarine shifts from execution to attrition, from singular events to cumulative pressure. This transition does not diminish the analytical clarity of the Barham case. On the contrary, it sharpens it. The engagement stands as a clean example of a system pushed beyond its temporal tolerance. There are no confounding variables, no technological surprise, no breakdown in discipline. The outcome follows directly from the parameters in play. That is why it remains useful. It isolates the mechanism of failure without noise. In professional study, the event is often used to illustrate the difference between resilience and robustness. The British formation is robust. It can absorb losses, sustain damage, and continue operations. It is not resilient to instantaneous failure modes. Resilience requires the ability to recover before effect propagates. In the Barham case, propagation is faster than recovery. The system cannot reconfigure in time. Robustness is irrelevant once resilience is overwhelmed. The same distinction applies to U-331. The submarine is resilient in the sense that it can evade, hide, and endure pressure over time. It is not robust in the face of immediate counteraction once it has revealed itself. By choosing proximity, it sacrifices resilience for effect. The trade is rational under the conditions present. It becomes irrational as those conditions change. As anti-submarine warfare evolves, the emphasis on resilience increases. Systems are designed to degrade gracefully rather than fail catastrophically. Detection gaps are overlapped. Response authority is distributed. Automation absorbs some of the temporal burden. These measures do not eliminate risk. They spread it. The goal is to ensure that no single lapse measured in seconds can undo the entire defensive architecture. The Barham sinking thus occupies a precise place in the evolution of naval thought. It is neither an outlier nor a paradigm. It is a boundary event that clarifies where one regime ends and another begins. Before it, assumptions about survivability tolerate narrow temporal margins. After it, those margins are treated as unacceptable. In the broader sweep of the war, this recalibration contributes to a gradual stabilization of outcomes. Catastrophic surprises become less frequent. Losses continue, but they occur within expected parameters. The system absorbs them. The dramatic asymmetry displayed in 1941 gives way to a more regulated contest, where advantage is accumulated rather than seized in a single instant. Yet the fundamental lesson remains unchanged. Wherever a weapon can deliver decisive effect faster than a defender can perceive, decide, and act, vulnerability persists. The platforms involved may differ. The environment may change. The physics does not. Time remains the decisive medium. The story of U-331 and HMS Barham, therefore, concludes not with closure, but with integration. The event is absorbed into doctrine, training, and design. Its specifics fade. Its principle endures. Modern warfare continues to revolve around the same equation, expressed in different variables: execution time versus response time, energy expenditure versus recovery, geometry versus inertia. In November 1941, that equation briefly favors the attacker. The result is immediate and irreversible. There is no correction phase, no second chance. The system fails cleanly. That clarity is what gives the event its lasting analytical value, and why it continues to be examined long after the ships themselves are gone. With this integration complete, the engagement ceases to be treated as an episode and becomes a reference constant. Later analyses do not revisit the narrative sequence. They reference the boundary it defines. When planners evaluate new formations, new escort doctrines, or new sensor configurations, they implicitly ask whether any configuration recreates the Barham condition. If it does, it is rejected before trial. The event functions as a negative template, shaping decisions by exclusion. This has measurable consequences for fleet design. Escorts are no longer optimized solely for weapon delivery, but for sustained presence within defined reaction radii. Their value is calculated in seconds generated rather than contacts destroyed. A destroyer that never fires a weapon but consistently extends warning depth by 45 seconds is more valuable than one that scores an occasional kill but allows proximity to collapse. Effectiveness is reframed as temporal stewardship. The same logic alters how commanders interpret silence. The absence of contacts is no longer reassuring if it coincides with degraded detection conditions. Silence inside compressed envelopes is treated as risk, not safety. This reverses earlier intuitions. Quiet becomes suspect when the system's ability to perceive has narrowed. Barham illustrates that a lack of warning does not imply a lack of threat. It may indicate that the threat has already crossed the decisive threshold. From the submarine perspective, this redefinition further constrains the use of stealth. Stealth that produces proximity without preserving escape margin is a one-time asset. Once expended, it yields no future utility. Submarine operations increasingly emphasize stealth that buys time rather than proximity. Remaining unseen at 1,500 meters is more valuable than appearing at 300. The former preserves options. The latter consumes them. In analytical terms, the engagement crystallizes the concept of irreversible commitment. Both sides cross points from which retreat is no longer possible. The battleship commits to a formation speed and geometry that cannot be altered within the remaining interval. The submarine commits to an attack that exhausts its capacity to evade. The asymmetry lies only in sequence. One commitment precedes effect. The other follows it. This sequence is what planners seek to control. If defensive commitments can be delayed until after detection, recovery remains possible. If they precede detection, recovery may be mathematically impossible. The Barham case demonstrates that commitment without awareness is the most dangerous state a system can enter. Awareness without time is functionally equivalent to ignorance. As naval warfare continues to evolve, the material specifics of the case recede, but the structural insight persists. Automation reduces some delays, but introduces new dependencies. Sensors improve, but also generate more data, increasing the risk of overload. The challenge remains the same: to ensure that the chain from perception to action remains shorter than the chain from approach to effect. The race is continuous. It has no final winner. In this sense, the sinking of HMS Barham is less a conclusion than an origin point for a mode of thinking. It marks the moment when naval analysis begins to privilege timing over strength with explicit numerical rigor. From that point on, any system that cannot demonstrate temporal superiority under worst-case conditions is treated as provisional. The endurance of this lesson explains why the case remains relevant long after the platforms involved have vanished. The variables have changed names, but not meaning. Distance still converts to time. Speed still determines compression. Energy still limits endurance. Human reaction still introduces delay. Where these factors align unfavorably, outcomes remain abrupt and uncontestable. Thus, the engagement continues to inform not because it was dramatic, but because it was exact. It exposes a failure mode that is neither accidental nor moral, but structural. It shows that modern military systems do not fail gradually. They fail when margins collapse below a critical threshold. And when they do, failure propagates faster than any corrective action can be applied. That recognition, once absorbed, cannot be unlearned. It shapes how forces move, how they wait, and how they decide not to engage. It embeds caution not as timidity, but as calculation. The Barham sinking, reduced to its essentials, becomes a permanent reminder that in war, time is not merely a dimension in which events occur. It is the medium through which control either persists or disappears, often in less than a minute. At this stage, the analytical weight of the engagement shifts almost entirely from tactics to structure. The sequence no longer needs to be retold to exert influence. Its parameters have been internalized. What remains is the systemic implication. Once a military organization acknowledges that catastrophic failure can occur without warning inside a compressed temporal envelope, it must reorganize around preventing that envelope from forming. This reorganization is subtle but pervasive. Planning horizons lengthen in some dimensions and shorten in others. Strategic movements are planned further in advance to ensure that local conditions never force decisions under extreme time pressure. At the same time, tactical responses are stripped to essentials so they can be executed instantly when required. This bifurcation reflects an acceptance that time can be abundant at one level and vanishingly scarce at another. The error lies in assuming that abundance at one level compensates for scarcity at the other. Barham demonstrates that it does not. The engagement also clarifies the limits of human-centered control in high-speed environments. Even well-trained crews require finite time to perceive, interpret, and act. These limits are biological. They cannot be trained away entirely. When weapon systems operate inside those limits, reliance on human intervention becomes untenable. This recognition accelerates the shift toward automation, not as a substitute for judgment, but as a means of preserving reaction margin. Automated alarms, automatic course alterations, and pre-programmed evasive actions are justified by the arithmetic exposed in 1941. Yet automation introduces its own constraints. It reduces latency, but also reduces flexibility. Automatic responses may trigger in situations where human judgment would have chosen restraint. The balance is again temporal. The cost of unnecessary action is weighed against the cost of delayed action. Barham pushes that balance decisively toward action. In compressed envelopes, restraint is no longer a virtue. From an organizational perspective, this leads to a redistribution of responsibility. Authority is moved downward and outward, closer to sensors and actuators. The traditional concentration of decision-making at the center proves incompatible with scenarios where decisive intervals are measured in tens of seconds. Decentralization is not ideological. It is mechanical. It shortens paths. The submarine community absorbs a parallel lesson. Attacks that require perfect execution under extreme time pressure are inherently unstable. They magnify the consequences of small errors. As defensive systems improve, the probability of such errors increases. Submarines that survive longest are those that avoid forcing themselves into terminal commitments. Persistence replaces audacity as the dominant measure of effectiveness. This evolution does not diminish the significance of U-331's success. It contextualizes it. The attack is understood as a product of a transitional moment, when offensive and defensive timescales briefly intersect unfavorably for the defender. Once that intersection is recognized, it becomes a target for elimination. The system adapts. The moment passes. What remains is the general principle. In any complex military system, there exist regions of parameter space where control collapses abruptly. These regions are often narrow and counterintuitive. They are revealed not by average performance, but by edge cases. Barham is one such case. It exposes a cliff, not a slope. The enduring value of the case lies in its measurability. Analysts can assign numbers to each step. They can show precisely where margin disappears. This precision strips away narrative comfort. It leaves no room for explanations based on character, morale, or chance. The outcome follows directly from configuration. As warfare continues to accelerate, the relevance of such cases increases rather than diminishes. New technologies compress time further. Hypersonic weapons, autonomous systems, and network sensors all operate on scales that challenge human-centered control. The fundamental equation remains unchanged. If execution outruns response, control is lost. The sinking of HMS Barham thus occupies a quiet but durable place in military thought. It is not invoked for inspiration or warning, but for calibration. It defines a limit. It reminds planners that safety margins are real, finite, and perishable. Once consumed, they cannot be restored mid-event. In this sense, the engagement completes its analytical journey. It begins as an unexpected loss. It becomes a case study. It ends as a constraint embedded in doctrine. The ships themselves vanish from service. The lesson persists, encoded not in memory, but in procedure. And that is perhaps its most consequential effect. The event no longer needs to be remembered to matter. It operates silently, shaping decisions that prevent its recurrence. Where time is preserved, nothing dramatic happens. Where it is lost, catastrophe follows too quickly to be narrated. The Barham sinking teaches how to avoid that silence becoming fatal by ensuring that, when the decisive seconds arrive, they belong to the defender, not the attacker. At the outermost level, this silent integration produces a paradox. The more successfully the lesson is absorbed, the less visible its influence becomes. Fleets that never experience a Barham-like loss appear merely cautious, methodical, even uneventful in their operations. Yet that uneventfulness is the product of continuous temporal management. Disasters are avoided not by dramatic counteraction, but by ensuring that the conditions for disaster never coalesce. This produces a measurable shift in operational metrics. Success is no longer counted primarily in enemy units destroyed, but in intervals preserved. Patrol reports begin to emphasize minutes of early warning gained, degrees of uncertainty reduced, seconds removed from command latency. These values are aggregated and tracked. A formation that completes a transit without ever allowing warning depth to fall below a defined threshold is considered to have performed well, regardless of whether contact was made. The Barham case provides the negative benchmark against which these metrics are judged. It defines what happens when warning depth collapses entirely. All subsequent measures are oriented toward ensuring that collapse cannot occur unnoticed. The system's health is assessed continuously, not episodically. Temporal margin becomes a status indicator as critical as fuel or ammunition. This logic also reshapes how intelligence is valued. Strategic intelligence that predicts submarine deployment weeks in advance is useful, but operational intelligence that identifies probable approach vectors hours in advance is more valuable because it preserves local margin. Tactical intelligence that identifies a contact seconds before effect is too late. The hierarchy of intelligence shifts downward in time scale. Information is ranked by how much time it can buy. For submarine forces, the same hierarchy applies inversely. Intelligence that reveals convoy routes days in advance allows careful positioning. Intelligence that reveals a target's exact position moments before contact offers little advantage if approach geometry is already constrained. The premium moves to anticipation rather than reaction. Submarines that rely on last-minute opportunities increasingly find those opportunities foreclosed. In this environment, the Barham engagement is recognized as a terminal phase interaction. Both sides enter a state where anticipation has ended and reaction alone remains. The side with the shorter execution chain prevails. The strategic contest, however, is decided earlier by whether such terminal phases are allowed to form at all. As naval warfare progresses through the remainder of the conflict, this emphasis on preclusion becomes dominant. Catastrophic single-event losses become rarer, not because weapons are less lethal, but because systems are arranged to prevent lethal timing alignments. Losses still occur, but they occur as accumulations rather than instant collapses. The system absorbs them. This absorption is itself a form of control. It ensures that no single event can dictate outcomes beyond its immediate scope. Barham stands out precisely because it violates this principle. Its loss propagates instantly and irreversibly. The shock lies not in the sinking, but in the speed with which consequence outruns response. Over time, this understanding influences not just naval warfare, but joint operations. Air and surface forces coordinate to extend warning depth. Patrol aircraft are tasked not to hunt aggressively, but to maintain continuous presence that denies approach windows. Even when no submarine is detected, the aircraft's mere existence stretches time. Absence becomes dangerous. Presence becomes protective. The analytical clarity of the Barham case allows these adaptations to be justified without recourse to speculation. There is no need to argue that a submarine might succeed again under similar conditions. It already has. The burden of proof shifts. Any plan that recreates similar temporal compression must explain why it will not fail the same way. Most cannot. They are discarded. Thus, the engagement's influence persists as a constraint on imagination. It limits what planners are willing to attempt. Boldness is not eliminated, but it is bounded by arithmetic. Courage is expressed through patience and restraint rather than proximity. This marks a cultural shift as much as a doctrinal one. In the final analysis, the sinking of HMS Barham occupies a unique position. It is neither representative nor anomalous. It is precise. It identifies a failure mode with such clarity that it becomes unusable thereafter. Once seen, it cannot be unseen. Systems evolve to avoid it instinctively. That avoidance is quiet. It produces no monuments. It leaves no dramatic footage. Its success is measured in the absence of events. Yet it shapes the conduct of war as profoundly as any victory. By revealing how quickly control can vanish when time collapses, Barham ensures that future control is preserved by never allowing that collapse to begin. And so the engagement recedes into the background of professional memory, not forgotten, but transformed. It ceases to be a story and becomes a boundary, a line that doctrine will not cross. A reminder that in modern war, the most decisive battles are often those that never occur, because the seconds that would have decided them were never surrendered in the first place. Beyond this point, the Barham case functions less as a lesson about submarines or battleships and more as a template for understanding how modern military power self-regulates. Once a system recognizes a catastrophic timing failure, it reorganizes to avoid recreating the preconditions. This self-regulation does not require continuous reference to the original event. It is embedded in procedures, checklists, and constraints that quietly shape behavior. Operational orders increasingly encode time implicitly. Phrases such as maintain contact, close the datum, or press the attack are replaced by quantified thresholds. Maintain separation sufficient to preserve 90 seconds of response margin. Avoid geometries where estimated time to effect falls below 45 seconds. These values are not theoretical. They are derived from observed limits. Barham provides one such limit, clearly demonstrated and empirically verified. This quantification alters how uncertainty is treated. Uncertainty is no longer inherently dangerous. What is dangerous is uncertainty combined with proximity. At long range, uncertainty can be tolerated because time remains available to resolve it. At short range, uncertainty becomes lethal. The system therefore prioritizes actions that increase distance when certainty cannot be achieved quickly. Withdrawal under uncertainty becomes rational rather than cautious. The arithmetic is clear. In practical terms, this leads to more frequent disengagements. Contacts are broken deliberately to restore margin. Pursuits are abandoned when they threaten to collapse timing buffers. These decisions can appear indecisive when viewed without context. Within the temporal framework shaped by Barham, They are decisive acts of preservation. They ensure that control is retained rather than gambled. For submarine forces, the same framework enforces restraint. The decision to attack is increasingly conditioned on post-attack survivability rather than immediate effect. If the energy budget required to escape exceeds remaining capacity, the attack is deferred. This shifts the emphasis from singular dramatic results to cumulative operational impact. The submarine becomes a persistent constraint on enemy movement rather than a vehicle for terminal shock. This persistence feeds back into the defensive system. Continuous low-level pressure is easier to manage than sporadic catastrophic loss. It allows defenses to adapt gradually rather than react violently. The Barham loss is violent precisely because it arrives without gradation. It compresses consequence into seconds. Systems learn to prefer threats that unfold over hours or days, because those threats can be countered incrementally. From an analytical standpoint, this preference reflects a deeper truth about complex systems. Gradual stress can be accommodated. Sudden overload cannot. The Barham engagement represents sudden overload in its purest form. All defensive capacity is bypassed in a single, brief interval. There is no opportunity for adaptation. The system either withstands the interval or fails entirely. As a result, later doctrine emphasizes buffering. Redundancy is designed not just to provide backup capability, but to stretch time. Multiple layers of detection overlap, so that failure of one does not immediately collapse margin. Decision authority is distributed so that delays in one node do not stall the entire response. Automation is introduced selectively to eliminate predictable delays. Each measure adds small increments. Together, they transform seconds into minutes. The success of these measures is difficult to observe directly. When they work, nothing happens. No torpedoes strike. No ships sink. The absence of disaster becomes the indicator of effectiveness. This makes such systems vulnerable to complacency. Barham's enduring role is to counter that complacency by reminding planners what happens when buffers erode unnoticed. In professional education, the case is therefore used sparingly but deliberately. It is introduced not as a dramatic narrative, but as a boundary condition. Students are shown the numbers, distances, speeds, reaction times. They are asked not how the attack succeeded, but whether it could succeed again under altered parameters. The exercise is diagnostic. It trains intuition to recognize when a system is approaching collapse. This intuition becomes critical as technology accelerates. Faster weapons reduce execution time. Networked sensors reduce detection latency, but increase cognitive load. Autonomous systems promise speed, but introduce new failure modes. The challenge remains unchanged to ensure that the defender's response curve stays ahead of the attacker's execution curve under worst-case conditions. Barham is an early, clear example of what happens when it does not. In this way, the engagement transcends its historical moment. It becomes a conceptual tool for thinking about speed, decision, and control. The specific ships, commanders, and circumstances recede. The structure remains. Whenever analysts encounter a system that appears robust, yet operates with minimal temporal margin, the same question arises. Where is the Barham point? Where does control collapse if timing aligns unfavorably? That question has no final answer. It must be asked repeatedly as systems change and environments evolve. The value of the Barham case lies in providing a concrete reference against which such questions can be grounded. It shows that collapse is not hypothetical. It has occurred. It occurred quickly. And it occurred not because of error, but because margins were insufficient. As long as warfare involves systems interacting at high speed under uncertainty, this insight retains its force. Control will always be conditional. It will always depend on preserving enough time to act. Once the time is lost, no amount of strength can restore it. The sinking of HMS Barham remains a precise demonstration of this reality, embedded quietly but permanently in the logic of modern war. The sinking of HMS Barham, when placed at full historical scale, marks less the end of a ship than the end of tolerance. It exposes the moment when industrial-age naval power reaches a threshold where mass, armor, and tradition cease to guarantee control, and where control becomes conditional on something far more fragile: the preservation of time under pressure. What occurs in November 1941 is not a reversal of dominance, but a revelation of limits that had already been forming beneath the surface of doctrine. In the years before the war, capital ships are conceived as instruments of sustained influence. They are built to endure damage, to absorb shock, to impose presence over hours and days. Their protection schemes assume that threats will announce themselves through gradual escalation. Gunnery exchanges unfold over minutes. Air attacks develop over visible approach vectors. The defensive system is therefore designed to trade time for survivability. Damage is expected, but control is assumed to persist long enough for correction. U-331 disrupts this assumption not through novelty, but through compression. The attack collapses an engagement that the defensive system expects to unfold over minutes into an interval measured in seconds. No part of the British fleet fails in isolation. Sensors function within specification. Crews act with discipline. Machinery responds as designed. What fails is the aggregate assumption that acceptable delays can be absorbed. When those delays align, the system crosses a boundary from which no recovery is possible. Historically, this boundary appears only briefly. It exists at the intersection of transitional doctrines, incomplete integration of air power, and the physical limits of both submarines and battleships operating near their respective envelopes. Within 2 years, most of these conditions are altered. Air patrol coverage expands. Escort doctrine matures. Reaction cycles shorten. The overlap that allows Barham to occur contracts until is nearly eliminated. The event therefore resists repetition, not because it is discounted, but because it is understood. Its long-term impact lies in how it reframes causality. After Barham, catastrophic loss is no longer explained primarily by surprise, daring, or error. It is explained by margin collapse. Analysts no longer ask who failed, but which buffer vanished first. This shift moves responsibility from individuals to structures. It encourages redesign rather than recrimination. Doctrine evolves not to punish deviation, but to prevent conditions in which deviation no longer matters. At strategic scale, this contributes to a broader stabilization of naval warfare. Single events become less decisive. Power is expressed through sustained pressure rather than terminal shock. Control is maintained by avoiding irreversible states rather than winning dramatic engagements. The war becomes more procedural, more constrained, and in many ways less visible. That invisibility is a sign of success. Where margins are preserved, outcomes remain controllable. In this sense, HMS Barham occupies a paradoxical position in history. It is remembered precisely because it demonstrates what must never be allowed to happen again. Its destruction clarifies a rule that later practice obeys instinctively. When execution outruns response, strength is irrelevant. That rule survives the war. It migrates into post-war planning, into automated systems, into doctrines that assume human reaction alone is insufficient under extreme compression. Seen from distance, the event stands at the boundary between two eras. On one side lies a conception of warfare governed by endurance and gradual attrition. On the other lies a conception governed by speed, latency, and irreversible thresholds. Barham falls at the moment those conceptions overlap, when old assumptions are still in force and new realities are already decisive. The ship sinks quickly. The lesson does not. It persists because it is not tied to a specific technology or adversary. It is tied to a relationship between time and control that remains invariant. As long as weapons can deliver effect faster than systems can respond, similar boundaries will exist. They may be narrower, they may be harder to reach, but they cannot be eliminated entirely. The historical significance of U-331's attack therefore lies not in what it destroys, but in what it reveals. It shows that in modern war, the decisive resource is not firepower alone, but the ability to keep time from collapsing. When that ability fails, outcomes are instantaneous and final. When it is preserved, even overwhelming force can be managed. That understanding reshapes how power is exercised. It favors caution grounded in calculation. It rewards structures that preserve margin rather than gestures that consume it. And it ensures that the most important victories are often the ones that leave no trace, because the seconds that would have decided them were never surrendered.